So, what if I told you that one of the most powerful cancer therapies we've ever seen wasn't cooked up in some high-tech lab, but was actually found hiding inside a common frog? Yeah, let's get into this incredible story, because it's a biological mystery that could completely change how we fight cancer.
You know, it all kicks off with this really simple question that's been bugging scientists for years. Wild amphibians, especially frogs, just have these remarkably low rates of cancer compared to other animals. So what's going on? Is it just a biological fluke, or are they hiding some kind of powerful secret?
Well, meet the hero of our story, the humble Japanese tree frog. Researchers in Japan had a hunch that the answer to this whole cancer mystery wasn't in the frog's own cells, but in something living inside it.
The big idea was that maybe, just maybe, some unique bacteria living in the frog's gut were giving it this incredible cancer resistance. A totally fascinating idea, right? But first, they had to find the exact microbe that was doing all the heavy lifting.
And so the hunt was on. Researchers started this massive systematic search, not just in frogs, but in other reptiles and amphibians too, all to find this one specific bacterium with, hopefully, extraordinary anti-tumor powers.
And this was a really methodical process. First, they went out and collected gut bacteria from all kinds of species. Then, kind of like prospectors panning for gold, they had to isolate every single bacterial colony, grow them in the lab, and then start the screening process, first to make sure they were safe, and then to see if any of them had any cancer-fighting abilities.
The results from that hunt were pretty remarkable. They started with 45 different strains. Out of those, only 9 were even safe enough to move forward. And of those, most could only slow tumors down a bit. But three were really special. They actually made tumors shrink. And then there was one, just one, that was an absolute superstar.
I mean, this one strain just completely blew all the others out of the water. The results they saw in mice with colon cancer were, and I'm not exaggerating here, staggering.
Just take a look at this. In the control group, the tumors grew like crazy. The other pretty good bacteria, in the middle there, they managed to slow things down, which is great. But our star performer, a bacterium called Ewingella americana, it didn't just stop the tumor, it completely wiped it out. The tumor volume dropped to 0. Let that sink in for a second. A single injection of this one bacterium that came from a Japanese tree frog led to a 100% complete response rate in these mice. The tumors didn't just shrink, they completely vanished, and they didn't come back.
So let's properly meet our hero, Ewingella americana. The key to its superpower is right there in the definition. It's a facultative anaerobe, which is just a sciencey way of saying it loves and seeks out low-oxygen environments. And can you guess one of the most famously low-oxygen places in the body? Yep, the core of a solid tumor.
So this natural ability, this instinct to hunt for low-oxygen zones, is its secret weapon. It's like a heat-seeking missile for tumors. But how does it actually destroy the cancer once it gets there? Well, it turns out it's a brilliant two-pronged attack. First up, there's the direct assault. The bacteria get inside the tumor, they multiply, and they start killing cancer cells directly. But here's the really genius part. At the same time, they act like a giant flare, sending up a massive alarm signal that basically screams to the body's own immune system, "Hey, get over here. There's a huge problem and we need to attack it now."
You can really see that whole process in action here. The bacteria home in on the tumor, they start their own attack, but then they call in the cavalry, the body's own special forces, T cells, B cells, and especially these cells called neutrophils, which just flood the area to wipe out any remaining cancer.
The researchers have this absolutely perfect way of describing it. You see, a lot of cancers manage to survive because they're cold. They're basically invisible to the immune system. This bacterium comes in and turns that cold tumor hot, making it this bright, unmissable target that the immune system can no longer ignore.
Okay, so it works incredibly well in mice. That's fantastic. But the real question is, how does it stack up against the best cancer treatments we have right now? To find out, the researchers put it in a head-to-head competition with a top immunotherapy drug and a standard chemotherapy.
And when you put them side by side, it's really no contest. Look at the effectiveness. 100% complete response versus just slowing the tumor down. How about targeting? The bacterium actively hunts the tumor, while the others are way less specific. And then you get to safety and dosing. An excellent safety profile with just a single shot, versus multiple doses and a bunch of potential side effects for the other.
And this really just says it all, doesn't it? In this head-to-head study,
chemotherapy had a 0% complete response rate. The advanced immunotherapy drug, 20%. And the frog bacterium, a perfect 100%. I mean, it's not even in the same league.
But wait, because there's one more incredible benefit, and this might be the biggest of all. The treatment actually creates long-term immune memory. When the researchers tried to reintroduce cancer into the mice that were cured, their immune systems immediately recognized it and destroyed the new cancer cells. It's not just a treatment, it's like a vaccine against that cancer ever coming back.
So what does this all mean for the future? Well, this discovery could be opening the door to a whole new era of what people are calling living medicine, where we harness naturally occurring microbes to fight our absolute toughest diseases.
Now, of course, we have to be realistic. There's a long road ahead. This isn't going to be on pharmacy shelves tomorrow. Getting from these amazing early results to an approved therapy for people is going to take years of rigorous testing, probably following a timeline something like this. But the potential is just undeniable.
What makes everyone so optimistic about that journey is its incredible safety profile. Remember, this is a naturally occurring bacterium. It's not genetically engineered. Tests showed no organ damage. The body clears it out within 24 hours after it's done its job. And here's a big one. It's killed by common antibiotics, which means doctors could have a built-in off switch just in case it's ever needed.
So this truly remarkable discovery, something that came from just asking a simple question about frogs, really shows us the immense, untapped power that's just hiding in the natural world. It really makes you wonder, doesn't it? What other miracles are out there, swimming, crawling, and living all around us, just waiting for us to find them?